radius of 12 miles. Express the answers in terms of pi. So the formula of circumference is 2 pi into radius, and the formula of the area of the circle is pi into radius squared. So if we look at the diagram here, this is a circumference. It's like perimeter, but it's used for a square. And this is a radius. And here, this is area. So it's shaded inside the figure. So we look here. We know 2 pi into 12. It is 24 pi miles. And for the area, it is 144 pi square miles. So our answer is 24 pi miles. And 144 pi square miles. Problem number 2. Find the area of half of a circle with a diameter of 4 feet. So, as we can see from the figure, the diameter of this is 4 feet, and we're trying to find half the circle, which is radius. So that is equal to 2 feet. So now we can go into finding the area of the circle. So we know the area is pi into 2 squared, which is equal to 4 pi. But the 4 pi represents the full circle. We're trying to find half the circle. So our answer would be half of 4 pi is equal to 2 pi. Problem number 3. What fraction of the total area of the square ABCD is within the circle with radius of 4 centimeters as shown below? So as we see in the diagram here, we know the radius of this is 4 centimeters. So obviously the diameter is 8 centimeters. So using that 8 centimeters, it resolves to the length of the square. So then we go here, fraction of square inside the circle, which is equal to area of circle divided by area of square. So that is equal to pi times 4 times 4, which is equal to 16 pi, and 8 times 8 equal to 64. So that resolves us to 1 by 4 pi, or you could say 0.25 pi.
Go.
Problem number 4. A 12-sided figure has been drawn on a 1 centimeter times 1 centimeter graph paper. Each small box is 1 centimeter long and 1 centimeter wide. What is the area of the figure? So let's look at the grid. So we know it is 1 centimeter long, 1 centimeter wide. So now let's look at the actual figure. I can tell that this figure could be divided into 4 triangles and 1 big square. Area of figure equal to area of 4 triangles plus area of square. So area of triangle equal to the formula half times base times height. But in this case, we're using numbers instead of the base and times height. Area of triangle equal to half times 2 times 1 equal to 1 square centimeters. So area of 4 triangles equal to 4 times 1 square centimeters. So now we have found the area of the 4 triangles. Now we have to find the area of the big square here. Area of square equal to length into breadth. So now if we look at it, the length of it would be 3, and then the breadth of it would be 3. Because on a square, all sides are equal. And so now let's look at it. Equal to 3 times 3 equal to 9 square centimeters. So the 9 square centimeters represents the square. So now we have found the area of the triangle and the square. Now all we just have to do is add them. Area of the figure is equal to 4 plus 9 equal to 13 square centimeters.
Problem number 5. Trevor needs a new bicycle tire. His tire has a circumference of about 112 inches. What is the diameter of his tire? Round to the nearest tenth place. So for this problem, we had to use the circumference formula, d times pi or 2r times pi, to find the diameter. I prefer to use d times pi because d times pi is equal to diameter times pi, and it'd be easier to derive the diameter from this formula. So since we know circumference is 112 inches, we can write this equation. Okay, so pi can be written multiple ways. So there's 22 over 7, 3.14, 3.15, 3.1415, multiple ways. So in this problem it says round to the nearest tenth place. So we can use we had to use pi as 3.14 to 22 over 7, anything but the character pi. So I prefer to use 22 over 7 because 3.14 is much too big of a number and it'll be harder dividing and multiplying. So 22 over 7 is a fraction and it'll be easier to cancel things out. So for now, let's take pi as 22 over 7. And so since we're trying to find the diameter, we would want to isolate d. So let's divide both sides by 22 over 7. Okay, so 112 divided by 22 over 7 is nothing but 112 times 7 over 22. So now let's cancel all the numbers that we can cancel. So this would become 11 and this could become 56 because they're both divisible by 2. So now 56 times 7 divided by 11. So 56 times 7 is 392 divided by 11. So now that we know now that we have our fraction, we had to make it a decimal, nearest tenth place, hence a decimal. So let's make it a decimal. 392 divided by 11, 3. We can stop right here because it says round to the nearest tenth place, and we have our 10th digit here. And since the next number would be 40, 40 is divisible by 40 can be made 33 when we're dividing, and that would be 3. And since 35.63, if we round it to the nearest tenth place, it would still be 35.6. We can just leave 35.6 as is. So 35.6 inches is our answer. Problem number 6. Gene's frying pan is 14.5 inches in diameter. What is the circumference of his frying pan expressed in terms of pi? So to solve this problem, we have to use the circumference formula. There are two circumference formulas, 2r pi and d pi. So 2r pi stands for 2 times radius times pi. D pi represents d diameter times pi. In this problem, they give us the diameter, so it would be easier to use the diameter times pi. So let's replace d with 14.5, which 14.5 inches is the diameter. 14.5 pi. Okay, so let's read the second part of the question. What is circumference of his frying pan expressed in pi? So since 14.5 times pi it has a pi in it, we can just leave it as it is. We don't have to make it 3.14, 22 over 7, and thus. So our answer is 14.5 pi.
Problem number 7. Maria's front yard is shaped like a trapezoid with a dimension shown. What is the area of her front yard? So as we look at this figure here, we know that there's 2 bases and 1 height. So let's look at it. The base of it is 5 yards. And we look down here, it's 7 yards. So if there's 2 bases, we name them. This is base 1, and this is base 2. And our height is 4 yards. So now let's look here. Area of trapezoid equal to base 1 plus base 2 divided by 2 times height. So now we know that will equal to 5 plus 7 divided by 2 times 4. So as we know, 5 plus 7 is equal to 12. 12 divided by 2. And then let's look here. 12 divided by 2 times 4. So we all know that 12 divided by 2 is 6. And times 4, which is equal to 24, which resolves right here.
Problem number 8. Tom is jogging around a circular track. The diameter of the track is 80 meters. How many meters will he jog to return to his starting point? Express the answer in terms of pi. So, first let's draw a diagram of the circular track. So here is Tom's starting point. So, since Tom is jogging a circular track, it's the perimeter or the circumference in this scenario of the track. So to figure out this problem, we need to find the perimeter / the circumference. So since they give us the diameter, we can use the formula d pi, diameter times pi, to find the circumference. So, and since they express the answer in terms of pi, we can just put 80. Substitute 80 for diameter and leave it as 80 pi. So 80 pi is the circumference.
Problem number 9. Measure the angle labeled as acute, right, or obtuse. So as we can see from the problem is asking us to find the included angle between these arms. So what I could tell is that this angle here is less than 90 degrees, which means it is acute. So I could also tell the included angle is 2 less than 20, so which is 18 degrees.
Problem number 10. Andy's taking a walk around the perimeter of a square park. One side of the park measures 2.5 miles. How many miles will he walk if he wants to reach his starting point again? So first, let's draw a map / diagram of the park. Okay. So here's the park. One side of the park is 2.5 miles. And since the park is a square, if one side is 2.5, then all the other sides are 2.5. Okay, so it says Andy's taking a walk around the perimeter of a square park. So the word perimeter hints at the fact that we're supposed to find the perimeter of the square. And so the question is, how many miles will he walk if he wants to reach his starting point again? So let's take his starting point to be right here. So he has to travel 2.5 miles plus another 2.5 miles plus another 2.5 miles plus another 2.5 miles to reach his starting point again. That is equal to 10. The amount of distance he walks is the same as finding the perimeter, and this would apply if he's right here, right here, right here, right here, or any point on the park. Because, well, if he travels this distance, then this leftover distance would come back here, since it would repeat. So it doesn't matter where he is, the amount of distance he will walk will always be 10. So therefore, the answer is 10. My name is Rishi and I'll be taking over for now. So problem number 11. A square-shaped room measures 6.5 feet on one side. What is the area of the room? Okay. So when it comes to word problems, we always first have to identify keywords. So keywords that I notice here are square-shaped room, 6.5 feet on one side, and area. Okay. So a square. Let's draw a diagram now. Okay. A square has 4 equal sides. And since it says 6.5 feet on one side, so 6.5 feet, we can assume that since it's a square, we can assume that all sides are equal. So we can say 6.5 feet, 6.5 feet, and 6.5 feet. Okay, so what is the area of the room? So the formula for area is height times length. Height times length. The height times length. So since the square has all sides of the square are equal, the height and the length are the same. So we can just say 6.5 times 6.5. So 6.5 times 6.5 is, well, let's do that. So 6.5 times 6.5 is 42.25. But we shouldn't forget the units, which is feet in this scenario. So it's 42.25 feet squared. Problem number 12. Identify the angles in the isosceles right angle triangle ABC with side AB and side BC having a length of 13.5. So the problem tells us to identify the angles A and angle C. And since it's an isosceles right angle triangle, let's try to identify the isosceles part of the isosceles right angle triangle. So if we flip this the triangle over, we will result in this model. Okay, this is the 90 degree. And since the sum of all the angles in a triangle is equal to 180, and the isosceles and an isosceles triangle has the same angles on the base, we know that 180 minus 90 is equal to 90, and the sum of these two has to be 90. And since they're the same, we can just divide 90 by 2 and we can get 45. So the angles of these are 45 degrees and 45 degrees. Problem number 13. What fraction of the total area of the rectangle ABCD is within each of the following sections? So to solve this problem, we had to find the area of the rectangle and then the area of each of the triangles. We're supposed to divide the area of each of the triangles by the total area of the rectangle. So first, let's solve for the area of the rectangle. So the formula to find the area of the rectangle is base times length. So in this scenario, base is 10 centimeters and length is 6 centimeters. So the area of the rectangle is 60 centimeters squared, because 10 times 6 is equal to 60. So let's write the denominator for each of these as 60 centimeters squared. Okay, next, we had to find the area of each of the triangles. So the area of triangle AED or ADE is base times height divided by 2. So here, since this is a rectangle, this length would apply to this side too. So this is also 6 centimeters. So the height of ADE is 6 centimeters, and the base is 2 centimeters, or AE, segment AE. So it's 6 times 2, and then we had to divide that by 2. 6 times 2 divided by 2. That is equal to 6, because 6 times 2 is equal to 12, and we're supposed to divide that by 2. That's 6. So 6. So next is triangle EDC. So triangle EDC, this is triangle EDC. So we're supposed to just input the measurements into the formula that we have. So the height of this triangle is 6 centimeters, because this is the height or the altitude, and the base is 10 centimeters because the triangle's base is 10 centimeters. So it's 10 times 6, and then we had to divide that by 2. 10 times 6 divided by 2. That is equal to 60 divided by 2, or 30. So 30. 30. Okay. So now triangle ECB. ECB. So we had to use the formula once again, and the height is 6 centimeters and the base is 8 centimeters. So it's 8 times 6 divided by 2. So 8 times 6 divided by 2, which is equal to 48 divided by 2, and that's 24. So 24 is the area of this triangle. Okay. So now, all of these fractions can be simplified further, and we forgot to input the units. So first let's simplify the fraction. This is 1 over 10 centimeters squared, or 1 over 10 centimeters squared, and this is 1 over 2 centimeters squared. This is 24 divided by 60 centimeters squared, so we can reduce that to 12 and 30. 12 and 30 centimeters squared. And then we know that it's divisible by 3. Both of these are divisible by 3. So we can say 4 divided by 10 centimeters squared, and they're both of them are divisible by 2. So it's 2 over 5 centimeters squared. Okay. So the answer is 1 over 10 centimeters squared, 1 over 2 centimeters squared, and then 2 over 5 centimeters squared. Problem number 14. Jasmine is making a display board for the school talent show. The display board is 10 feet by 9 feet rectangle. If ribbon costs $2 per foot, how much will it cost to add a ribbon border around the entire display board? So a keyword you should identify is a ribbon border. So border usually refers to perimeter, and it's a display board, rectangular display board. So we try to find the perimeter of the rectangular display board. Let's draw a diagram first. That's a rectangle, and it's 10 feet by 9 feet. So 10 feet by 9 feet. So first let's find the perimeter. So the perimeter of this is, it's 9 times 2, because 9 and 10 plus 10 times 2. So it's 20 plus 18. That is 38. So that's the perimeter. And now that'll be 38 feet. And now since it costs $2 per foot, we had to multiply 32 times $2. And that is equal to $76. Problem number 15. Danny has a rectangular rose garden that measures 8 meters by 10 meters. One bag of fertilizer can cover 16 meters squared. How many bags will he need to cover the entire garden? So to solve this problem, first we had to find the area of the rectangular rose garden. So the rectangular rose garden, it's a rectangle. So the formula to find the area of a rectangle is length times height. And the length in this scenario would be 10 meters and the height is 8 meters. So it's 10 times 8. 10 times 8 is 80. So the area of the rectangular rose garden is 80 meters squared. Next, we have to find how many bags will he need to cover the entire garden. So in order to find the number of bags, we had to divide 80 meters squared, divided by 16 meters squared. We're dividing it by 16 meters squared because one bag covers 16 meters squared, and we had to find the amount of bags. So if we divide this, we should get that's just 10 times 8 meters squared divided by 8 times 2 meters squared. We can cancel the 8 and the 8, so we're left with 10 over 2, and that's just 5. So it's 5 bags. Yep, 5 bags of fertilizer. Problem number 16. The floor of Taylor's bathroom is covered with tiles in the shape of triangles. Each triangle has a height of 7 inches and a base of 12 inches. If the floor of our bathroom has 40 tiles, what is the area of the bathroom floor? To solve this problem, first we had to find the area of a triangle, of the triangle, and then we had to multiply it by 40, or the number of tiles. So first let's draw a diagram. So if this is a tile, then the base would be 12 inches, and the height would be 7 inches. So to find the area of a triangle, it's base times height divided by 2. So here the base is 12, so it's 12 times, and the height is 7. 12 times 7 divided by 2. So if we simplify this, we get 84 divided by 2, and 84 divided by 2 is 42. So now that we know the area of one tile / triangle, we had to find the area of 40 tiles. So we just had to multiply 42 times 40. 40 can be split into 10 and 4. So we can multiply 42 times 10, or 42 times 4 first, and then we can multiply by the other one. So first, let's multiply 42 times 4. So 42 times 4 is equal to 168. So now that we've done 4, we can multiply 168 times 10, and that's just 1,680. So our answer is 1,680 inches squared.
Go.
Problem number 17. In quadrilateral ABCD, sides AB and BC are of length 10 centimeters each. Sides AD and DC are of length 17 centimeters each, and the measure of angle ADC is 60 degrees. What is the length of the diagonal AC? So they're asking us for the length of diagonal AC. So to figure out the length of diagonal AC, we gotta fill in the blanks. The blanks would be the angle, these two angles, and the side length, and yeah, this is side length. So since side CD and AD are the same, we can say that triangle ACD is isosceles. Since it's isosceles, these two angles have to be the same. And since all the sum of all the angles in a triangle is 180, we can subtract 180 minus 60 to get 120. And then we can divide that by 2 to get the measure of each of these, since these both angles would be the same. So if we divide 120 by 2, we get 60. So this angle is 60, and this angle is 60. And since it's isosceles, and since all the angles are the same, it's an equilateral triangle, which means that all the sides are the same. So if this is 17, and this is 17, and this would also be 17. So side AC is 17 centimeters. So 17 is our answer. Problem number 18. Anastasia's tablecloth has a regular pattern as shown in the diagram. What percentage of their tablecloth is black? So to solve this problem, first we had to find the area of the full square. So the area of the full square is, well, the area of a square is base times height, or length times height. And in the diagram on your paper, the length of 5, or the bottom 5 squares, is the same as the base, or the length of the square. So if we take the diagonal of each square as x, then we should get the side length to be, or the length of the side to be 5x. So 5x on one side, and since it's a square, and because there's 5 on each side, this would be 5x, and this would also be 5x. So if to find the area would be 25x squared, because 5x is nothing but 5 times x. So it's 25x squared. So the denominator is 25x squared. And now to find the numerator. To find the numerator, we had to find the area of the square, of the medium square, and then add it with the area of all the smaller squares. But this is only the area for the white. We're trying to find the area of the black. So what we would do is we'd subtract 25x squared minus the area of the white. So first let's do 25x squared minus, okay. So if we notice, three of these squares, the diagonal of 3 of the squares is equal to one side length. So one side length would be 3x. And since it's a square, 3, 3, 3, there's 3 squares for each side. Since it's a square, this side would be 3 and this side would also be 3x. So, and then to find the area, it would be 3x squared. 3x whole squared. So it would be 25x squared minus parentheses 9x squared. Plus, because now that was just this, now we have to find the area of each of these smaller squares. Okay, here comes the tricky part. So, since we know that the length of the diagonal is x, we had to find the one side of the square. So the formula to find the diagonal for any regular quadrilateral, well, not really regular quadrilateral, but for a square and a rectangle is a squared plus b squared is equal to c squared. A squared would be one of the sides. So let's just zoom into one particular square. So that this is x. Okay, so this would be a and this would be b. This is how rectangles would work, and since this is a square, a and b are the same thing. So let's take b as a. So we'll just rewrite it as a. So then this would be rewritten as a squared plus a squared is equal to c squared, or c squared, yes. And c would be this length, a would be this, and a would also be this, because it's a square in this scenario. So let's input this inside the formula. So we have a squared plus a squared is equal to x squared. So we can simplify this further down to 2a squared is equal to x squared. And then we can find the square root of both because a squared and x squared is being squared. So if we square root it, we get square root of 2 times a is equal to x. So now let's solve for a. So if we divide both sides by negative square root of 2, we get a is equal to x over the square root of 2. That's what a is equal to. So now we're going to verify that that's what it is equal to. So we have, if we plug this in to here, if we plug this into here, we should get the answer as x squared. So let's do that. So we have x divided by the square root of 2 squared plus x divided by the square root of 2 whole squared. So this is equal to x squared divided by 2 plus x squared divided by 2. And that is equal to x squared. So yes, it does work. So the side length is equal to x divided by the square root of 2. So now to find the area of 1, we just had to multiply this by the height, which is also x divided by the square root of 2. And if we multiply this, we get x squared divided by 2. And now that we know the area of 1, we had to find the area of all of them. So we just had to multiply x squared divided by 2 by the number of squares there are. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 squares in total. So we just do x squared divided by 2 times 16. And we can just cross cancel here because 16 is divisible by 8, and so 8 is divisible by 2, and so 16. So we have 1 and 8. So now we have 8x squared for the area of the individual, for all the smaller squares. So we can just plug that in right here, plus 8x squared. So now this value 9x squared plus 8x squared is equal to the value of all the white. So if we simplify this, we get 25x squared minus 17x squared divided by 25x squared. So 25x squared minus 17x squared is nothing but 8x squared, and then we have 25x squared. So now, since 8x squared is nothing but 8 times x squared, and 25x squared is nothing but 25 times x squared, we can just cancel out the x squared in the numerator and the x squared in the denominator, so that we will be left with 8 over 25. Now we had to make 8 over 25 a percent. So one thing I noticed here was 25 times 4 is equal to 100, and percents go by hundreds. So if we multiply 24 times 4, we get a denominator of 100. So we have to multiply the numerator by 4. That is 32, which is equal to 32. And 32 over 100 is nothing but 32%. And 32% is our answer. Problem number 19. In the diagram below, a diameter of each of the two small circles is the radius of the larger circle. If the two smaller circles have a combined area of 1 square unit, then what is the area of the shaded region in square units? So to solve this problem, first we had to find the area of the large circle. So the area of the large circle, to find it, we had to use the formula, the area of a circle formula. And to use that formula, we have to find the radius. And in the problem, it states that the radius is nothing but the diameter of one of the two smaller circles. So, in order to find the diameter of one of the two smaller circles, we had to find the radius using the area of it. So, once we have the radius of it, all we had to do is multiply it by 2. So here, we were able to find out that the radius is square root of 1 over 2 pi. But how we got to the answer, I will explain now. So in the problem right here, the two smaller circles have a combined area of 1 square unit. What it says is that, what it explains is that if you add these two circles up, you get an area of 1. And if we take the area of one circle as pi r squared, we get 2 pi r squared is equal to 1. So 1 is equal to 2 times pi r squared. Pi times r squared. So since we're looking for the radius of one of the smaller circles, we had to solve for r. Not r squared, r. So let's solve for r. So first I divided the equation by 2 on both sides, and then I divided the equation by pi on both sides. Now we're left with r squared is equal to 1 over 2 pi. So now I'm going to square root both sides to get what r is equal to. So r is equal to the square root of 1 over 2 pi. So now that we know what r is equal to, we had to find the diameter of one of the small circles. So all we had to do is just multiply square root of 1 over 2 pi times 2. So we get 2 times 1 over square root of 1 over 2 pi. That is the diameter of one of these. So now we had to find the area of the large circle. So we input the radius slash the diameter of the small circle into the area formula. So we put this into pi times 2 square root 1 over 2 pi squared. So now we had to simplify this. So we get pi times 4 times 1 over 2 pi. We can simplify this down to 2 pi divided by pi. So now we can cancel out the pi and the pi, and we're left with 2. So 2 is the area of the large circle. But the question asks for the shaded region. So we had to subtract the area of the large circle minus the sum of the area of the small circle. It's given in the problem and it is 1. So it's 2 minus 1 is 1. So 1 is our answer. Problem number 20. The diagram shows a parallelogram W, X, Y, Z with the area S. The diagonals of the parallelogram meet at the point O. The point M is on the edge ZY. The lines WM and ZX meet at N. The lines MX and WY meet at P. The sum of the areas of triangles WNZ and XYP is is 1/3 of S. What is the area of quadrilateral MNOP? MNOP, just a quadrilateral. So to find this, to find MNOP, first we had to find this, and then we had to find WMX. So first, let's write the formula to find the area of a triangle. So the formula to find the area of a triangle is base times height divided by 2. So since the area of the parallelogram is S, the area of the parallelogram is S. So WX, the base of this triangle right here, this triangle, the base of that triangle is the same base as the parallelogram, and the height is also the same. So if it wasn't for the dividing by 2, it would be the same area. But since we're dividing by 2, this triangle WMX is equal to half of S, or the entire parallelogram. So we have half of S. Our goal right now is to be able to find these two first. So to find these two triangles, first we have to find this WMX, add it with these two triangles, and then subtract it from the total area S. Since we know the sum of these two triangles, and we know this triangle, we can add them together and subtract them from S. So 1/2 of S plus 1/3 of S is equal to, well, that's 3/6 of S plus 2/6 of S, which is equal to 5/6 of S. So this is equal to 5/6 of S. Okay. So this is equal to 5/6 of S. This right here, all of this. So now we have to subtract S minus 5/6 S, and that is equal to 1/6 of S. So now we know that these two triangles are equal to 1/6 of S. So now that we know that this is 1/6 of S, we can just write 1/6 of S here, record that down. Okay. We know these two are 1/6 of S. So next, we're supposed to find this triangle. So to find this triangle, we gotta find the intersection. So first, let's find the area of ZOY. Okay, so O is the intersection between WY and XZ. XZ and WY are diagonals that intersect the parallelogram. So therefore, O is the center of the parallelogram. So if you drew a line, a parallel line with WX across that intersects point O, we would have a line that is halfway between the parallelogram. So that means that the height of both of these triangles is half of the height of the parallelogram. So half the height of the parallelogram, and the base is the same still. So if we calculate that, we would find that one of these triangles is equal to 1/4 of S. So this triangle is equal to 1/4 of S, and so is this triangle right here. But all we need to know is this triangle, so 1/4 of S. So this triangle is equal to 1/4 of S, and these two are equal to 1/6 S. Now all we have to do is we have to subtract 1/4 of S minus 1/6 of S to find the intersecting part. Since we know this, we know all this, okay? And they're telling us to find this, so we had to take out all the intersecting parts. So to do that, we subtract 1/4 S minus 1/6 S, and that's equal to 3/12 S minus 2 over 12s. That is equal to 1 over 12s. So our answer is 1 over 12.
Don't forget to subscribe and like. If you have any questions, you can email info@agoramathcircle.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website, which is basically the end of the email but without the info and the end. So bye!